So dear students, today we again start with signal flow graph, a new and a complex questions. So once again I will show you the same how to solve the signal, how to find out the transfer function of a complex system using signal flow graph. To find out the transfer function of a system, we use the Mason's gain formula. Once again see this PPT. Yes. So see what is the Mason's gain formula? Mason's gain formula is used to determine the transfer function, means output divided by the input of a system from the signal flow graph, right? So let's suppose the input is Rs and output is Cs. Then the transfer function which we want to find is Cs upon Rs. Mason's gain formula is summation of Pk del k upon del. T is equal to 1 upon del summation of Pk del k, right? Or it is also we can say by I is equal to 1 up to n. What is the meaning of this? In any signal flow graph, when we will see any signal flow graph, as I told you in previous lectures, and we solve certain simple numerical on signal flow graph, the same formula is here. T stands for the transfer function. Is it clear? And P is the number of forward path gain, Tk del k upon del. So T is your number of forward path from the input side to reach at the output side. How many straight forward paths are there? That is your K. If there are 2 forward paths, then T1, T2 we have to find out. If there are 3 forward paths, then T1, T2, T3 we have to find out. The K is the number of forward path. Del we have to find out it in a very straightforward manner, that del is equal to 1 minus sum of individual loop gain plus sum of gain product of all possible combination of 2 non-touching loop, and so on and so on. And del k is the del for the part of the graph which is not touching the kth forward path. Okay, apart from the formula, when we will solve a complex numerical like the previous simple numerical on signal flow graph, you will be very much aware about how to solve the numerical, how to find out the transfer function with the help of a signal flow graph. So let's suppose this is let's suppose we use a complex question. So I just copy it and I will show this in a MS Paint so that you will easily see how to solve the numerical step by step. Okay. Yes. So now you are able to see this blank screen of MS Paint on which I just paste the same complex numerical, right? We have to find out the transfer function. First of all, whenever any signal flow graph is in front of you, what I told you, the first step is just see what is the name of the output, by which abbreviation the output is denoted, and by which abbreviation the input is denoted. Here the output is denoted by y6 and input is denoted by y1. So we have to find out the transfer function. It means we have to find out y6 upon y1. y6 divided by y1. Okay, so we have to find out this. Yes. So what is the formula which we have to use? First of all, we have to find out how many k are there. K is the number of forward path. As in the formula I told you, k is what? The number of forward path. So how many number of forward path we have to find out in this step? So C, how many number of forward path? C. What is the meaning of forward path? As I told in previous examples, forward path is from the input side. When you start from the input side and you will reach up to the destination, how many straight forward path? It means how many paths without repetition of the same node, without repetition of the same node. So now see, Here from the blue color line I will show you. Now I start from y1. Okay, so y6, that is my destination. So this is a forward path. So this is a forward path. So one forward path is A, B, C, D, E. One forward path gain is A, B, C, D, E. But this is my first forward path. And where is the second forward path? Now see, is there any other part left? Yes. We start from y1, that is my input side. Gain is A, then B, nothing is repeated. Then I jump at the upper side, which is denoted by the G in the questions. So G, then this E. Okay, so again I start from the starting point and reach up to the destination without repetition of any node. So these are two forward paths. Okay, so what is the value of k? So the same, because we find two forward paths, so here the forward paths are 2, here the number of forward paths are 2, k is equal to 2. So what I told you, whenever you, once you find out the value of k, it means now the formula is, we have to find out T1 and T2, because k denote you the number of forward paths. So T1 and T2 we have to find out, and del 1 and del 2 we have to find out. So now what will be the your formula, what will be the modified formula to find out the transfer function related to this numerical? So your transfer function is equal to now Tk del k T1 T1 del 1 T1, just wait for a while. Yes, T1 del 1 plus T2 del 2 upon del, because there are two forward paths, plus T2 del 2 upon del. Yes, once I will write down the formula, then it will be simplified. Once we find out the formula related to a particular numerical of signal flow graph, it will be very easy for us to find out the complete solution on del. Okay, so now for this question, your modified formula for the transfer function of this system is this one. So we have to find out the answer of this question, we have to find out what is T1, what is T2, what is del 1, what is del 2, and what is del. Now see step by step. What is the meaning of T1? As I have already been told you in the previous examples, in the numericals, and in today's second number PPT also, that T1 and T2 are the gain of the forward path, the forward path gains. So how many forward path we find? We find two forward path here. One is T1 and second one is T2. So what are their gains? So see what are their gains. So what is T1? Now T1 is what? Because in this question, with the blue color line which show in the diagram by forward path, I write down now with the same color, so that you will not be skeptic about how they are different. So now see, from the y1 we start. Now first is A, then B, then C, then D, and then E. So A, B, C, D, E is my gain. A, B, C, D, E is my gain. Now for the T2, in the diagram, as I mentioned few minutes ago with the green color pencil line, that this is my second forward path. Okay, so now I write down with the same color line the forward path, so you will not be skeptic about this. So A, B, then G and E. Paths. Okay, so these are two forward paths. Wait, I just save the file. Any name idea? Okay. Yes. Kindly wait. Okay. Yes. Now see. Now see. So this ABCDE and ABG is my two forward paths. Now we have to find out del 1, we have to find out del 2. What is the meaning of del 1, what is the meaning of del 2, and what is del? First of all, what is del? Before this, my second step is to find out the number of loops. But what is my next step? Now we find out, after finding out these two parameters, after finding out this number of forward paths, right, T1 and T2, we have to find out the number of loops. Now number of loop is what? Number of loop is any closed path. Once we start from a node, as I told in the previous examples, once we start from a node, we will move and again reach at the same node. Again reach at the same node means a closed path, that is known as node. That is known as node. But no branch is repeated here. Once a branch comes, there will be no movement on the same branch. Okay, so now we find out the number of loops for this question. Number of loops. Number of loops. So how many number of loops are there? See, now I will show you with this red color in the diagram, one loop. This is a closed path. Yes, this is a closed path. Okay, one loop. Now see, with this orange color I mentioned, this is closed path. Start from the D and again, and from the Y4 node. Start from the Y4 node. D is the gain. Reach at Y5 and again repeat and reach at the Y4 node. So this is my second loop. Now what is my third loop? See very clearly, it is a special loop. See with the purple color, this one. I start from the Y5 and reach at the same Y5 without repeating of any branch. So this one in which only one gain is there, that is F. Okay. Now the last one is, I mentioned with this brown color. C very clearly, I start from Y3, G is my gain, I reach at Y5, then H is my gain, I again reach at Y3. Okay, so there are four number of loops. So how many number of loops are there? There are four number of loops. So what are the gain of these loops? Now I write down the gain by L1, L2, L3. I just write down the abbreviation as L1 is equal to. Now see, the first loop which I draw was with red color, so I just again repeat with the L1. See the red circle in that pencil circle in that diagram. We mention a loop start from the Y2 node and reach again at the Y2 node without repeating any branch. So what was the gain in between there? In between its genre, B and G. So BG, I write down BG. These are my loop gain first. Now the second loop, I see the orange color circle, and now I write down the gain of that orange color circle. I start from the y4 node and again reach at the y4 node. In between the journey there are two gain, one is d and one is I. So what is the total gain of this loop? di. Okay, now see the third one, circle with the purple color. See the purple color circle in the diagram, that is my L3 loop. I start from the y5 node, again come at the y5 node without repetition of any branch, and now the last one with the brown color circulation I mention in front of you. So what is the loop gain there? That I start from y3, then g, then reach at y5, again reach at y3 without repeating any branch. So g and h in between there. So g, h. So these are four number of loops. So these are four number of loops. I find out here the four number of loops in this question. Now I see what is the meaning of del 1. Del 1 is which loop do not touch the first forward path. Which loop do not touch the first forward path. See, first forward path is A, B, C, D, E. All the loops, either it is Bj, either it is Di, either it is F, or either it is G forward path with for the first forward path, either with the node or either with the branch. So all the nodes touch the first forward path. So we can say that del 1 is equal to 1 only, because no free loop without touching the first forward path. So del 1 value is 1. Here for this question, del 1 value is 1. Now see the del 2. What is del 2? Del 2 is similarly which loop do not touch the second forward path. Which loop do not touch the second forward path. So now we find out the value of del 2 here for this question. Now when we look the question very carefully, so del 2, which loop do not touch the second forward path. Second forward path is A, B, G, E, A, B, G. So see, first loop Bj touch this first forward path, the second forward path. D, I also touch, the second loop also touch from the node y5, y5 ends. The loop L3 also touch from the y5 end, and the loop GH also touch from the branch G. So all the loop touch the second forward path. So here also del 2 value is also 1. Del 2 value is also 1. Okay. So now when we see the question, we find out T1, we find out del 1, we find out T2, we find out del 2. Only what we have to find out del. So now we work for this, and when we will find out and put in the same question, then we will completely find out the solution. Okay, now see. Yes. So as we know, what is the formula of del? We just follow the same formula as in the second PPT I show you, and in previous simple numerical related to this topic we solve. What is del? The formula for the del is 1 minus sum of all the individual loop gains. Sum of all the individual loop gains. So how many individual loop gains are there? Bj, Di, F and Gh. So sum of all of these. So Bj plus Di plus F plus Gh. Okay. 1 minus sum of all the individual loop gain plus sum of all the two non-touching loops. Sum of all the two non-touching loops. So now see how many two non-touching loops are there. So see, Bj is one loop, and di is the second loop. L1 and L2 are the non-touching loop. L1 and L2 are the non-touching loop. So sum of the product of all the two non-touching loops. So what are the product of these L1 L2? Bj di. So Bj di plus, now we check again, Bj cannot touch the loop L3. So Bjf, sum of the product of two non-touching loops. So L1 loop do not touch L3 loop. So L1 L3 product, that is Bjf, is again we have to sum here. Okay. Then the rest one, L1 touch the L4 loop, L3 also touch the L4 loop, and L2 also touch the L3. Okay. So now this one, two non-touching loop gain products ends. Now minus three non-touching loop, but here no three separate loop are there which do not touch each other. Here if we consider about L1, then definitely it do not touch L2 loop, but it touch L3 and L4. So similarly, there are none individual three loops which do not touch each other. So it means the formula of del will ends up to this value. So now we find out this value of del also. Now we find out this value of del. Okay. Yes. So what is the transfer function? Once again we talk about to find out the transfer function. So what is the transfer function? Now see the answer. Transfer function of this question is equal to T1. So what was my T1? T1 is my ABC